know the fourth one is event correlation technique. There are some simple method to diagnose and isolate the source of problem in fault and performance management. When centralized NMS receives a trap or notification, it is called as receiving an event. A single problem source may cause a multiple symptoms, and each symptom detected is reported as an independent event to the management system. Obviously, we don't want to treat each event independently and act to resolve it. Thus, it is an important that management system correlates all these events and isolate the root cause of problem. The technique used for accomplishing this is called as event correlation technique. There are several correlation techniques used to isolate and localize in networks. It is detecting and filtering of events, correlating observed event to isolate and localize the fault either topologically or functionally. Third one is identifying the cause of problem. So all these three cases there is an intelligence or reasoning behind the methods. Let us know the different approaches. There are six approaches to correlation techniques. First one is rule based reasoning, second one is model based reasoning, third one is cascade based reasoning, fourth one is code book reasoning, fifth one is state transition graph model, sixth one is finite state machine model. Let us study one by one in detail. The first one, the rule based reasoning. It is an earliest form of correlation technique, also called as a rule based expert system or expert system or a blackboard system. It consists of knowledge base, working memory, and inference engine. It has a three level representing in three components. Components are knowledge level, data level, and the control level. Looking to the figure shows a basic rule based reasoning paradigm. It consists of three important the levels: the working memory, inference engine, knowledge level. Here the knowledge base contain expert knowledge as to define a problem in network, action that need to be taken if particular condition occurs. The knowledge based information is rule based in the form of if then condition action containing rules that indicate which operations are to be performed. When the working memory contained as working memory elements, the topological and the statement in the form of network being monitored. When the network goes into a fault state, it is recognized by the working memory. Inference engine in cooperation with the knowledge base compare with the current state with the left side of the rule base and find the closest match to output the right side of the rule. The knowledge base then executes action on the working element. Looking into the figure, the rule-based paradigm is an interactive between the three components and is interactive. There are several strategies for the rule-based paradigm. A specific strategy is implemented in the inference engine. Choosing a specific rule, an action is performed on the working memory element, which could then initiate another event. The process continues until the correct state is achieved in the working memory. For all these concepts, we'll consider an example. We can define the alarm condition for the packet loss as follows. If packet loss is less than 10%, alarm green. If the packet loss is greater than equal to 10% and less than 15%, alarm yellow will buzzer. If the packet loss is greater than equal to 15%, alarm red is buzzer. One more example. Implementation of RPR, rule based, that is called rule based reasoning. It shows a four layer network backbone. A router A links to router B, and hub C is connected to router B, has four servers D1 through D4 in its LAN. Without a correlation engine, failure in the inference of router A will generate an alarm. These fault then propagate to router B, hub C, and finally to server D through D4. It is implemented to realize that there is a time delay involved in the generation of alarm. In general, propagation of faults and time delay associated with them need to be recognized as such in fault management. Looking into the figure, RBR based correlation example, there are components like backbone router A, router B, hub C, and the server, four server like D1 to D4. There are four correlation rules are specified below. Rule 0, alarm A, send a route cause alarm A. Rule 1, alarm B, if alarm A present related to A and ignore. Rule 2, alarm C, if alarm B present related to B and ignore. Rule 3, alarm DX, if alarm C present related to C and ignore. The correlation windows consist of 20 seconds. Here rule 0 has no condition associated with it, where rule 1, 2, 3 are condition rules. In order to allow for the propagation time, a correlation window of 20 seconds is set. The inference engine at the control level interprets these rules and take action and is shown in below. The figure shows control action for a RPR. A correlation window is equal to 20 seconds. Arrival of alarm A sent. Arrival of alarm B correlated by rule 1. Arrival of alarm C correlated by rule 2. Arrival of alarm DX correlated by rule 3. End of the correlation windows. Therefore, it can be observed that only alarm A is sent and other are ignored as long as they arrive within the correlation window. The alarm could be even be generated out of sequence. However, because of the specification of a correlation window size, the inference engine wait before sending alarm B, C and DX.